We can identify redox reaction by performing chemical tests, and we can detect the presence of the oxidizing and reducing agent. Let me explain what is the meaning of oxidizing agent and reducing agent first. Now, oxidizing agent is able to oxidize another substance. Reducing agent is able to reduce another substance. So what does that mean? It means that if, for example, I am going to give you one example here to make it more clear for you. If I know that my sodium bromide and my chlorine bromine gas plus 2 sodium chloride, from here to here, this one is a bromide and this one is a bromine. This is a -1. This one is a 0 charge. I call it an oxidation. So itself is oxidized. I will call this a reducing agent because it reduces the chlorine, reduces. Same thing for chlorine over here. Chlorine to chloride, it is a reduction. Okay, why is it reduction? Because chlorine is 0, chloride is -1. There is a reduce in oxidation state. If there is a reduction happening here, this one is an oxidizing agent. Okay, so this one causes oxidation. This one causes chlorine to be reduced. I would like you to take a look at this whole thing again. Now, sodium bromide is oxidized. Sodium bromide is oxidized. Sodium bromide, there is an oxidation here. Sodium bromide is oxidized. So it is a reducing agent because it reduces chlorine to chloride. Chlorine is an oxidizing agent because it causes sodium bromide to be oxidized. I hope this clarifies. I'm going to give you another example here. Now we got silver nitrate plus copper, 2 silver plus copper nitrate. Silver to silver. This one is a reduction. Okay? Then this one itself is an oxidizing agent. That means it oxidizes the other party. But for copper, if I have this one here, copper to copper here, this one is an oxidation. Then I can safely say my copper is a reducing agent because it reduces the silver nitrate. This one, it oxidizes the copper. It oxidizes the other party. So the oxidizing agent and the reducing agent, they will be both from the reactant side. Oxidizing agent will oxidize the other party. They will oxidize the other party. Reducing agent, they will reduce the other party. I hope this clarify for the oxidizing agent and reducing agent. So another way to help you to explain is that, for example, oxidizing agent in this case, this is my oxidizing agent. My chlorine will change to chloride. This is a reduction itself. If it's a reduction, it is an oxidizing agent here. If this is your iodide, example, this is your potassium iodide, iodide to iodine gas, it is an oxidation process, but itself is a reducing agent that reduces the second party, not itself but second party. So this definition is important, and you are required to remember the examples of oxidizing agent and examples of reducing agent. Identifying the oxidizing agent and reducing agent, I'm going to help you to understand this. If I have zinc to zinc plus, this is a 0 and this is a plus 2. 0 to plus 2 is an increase in oxidation state, so it is an oxidation. If it's an oxidation, this is a reducing agent. So reducing agent is your zinc. If copper to copper here, copper is a 0 and copper to sulfate is a 2 plus. So 2 plus to 0 is a reduction, decrease in oxidation state. So this is a reduction. If this is a reduction, my oxidizing agent is copper to sulfate. I hope this clarifies. Another example is my nitrogen. Nitrogen in this case, nitrogen oxide to nitrogen. N2 minus, this is a 2 plus. This one is a 0. If I can see my nitrogen here, wait, sorry, nitrogen here, this one is a 0. This one is a plus 2. So this one is a reduction. If it's a reduction, then that one is called an oxidizing agent. So nitrogen oxide is an oxidizing agent. Carbon to carbon dioxide, this one is a plus 4, plus 2. Carbon is a plus 2. And this one is a plus 4. This is a increase. So increase in oxidation, so reducing agent is carbon monoxide. Last segment for today's session will be testing the presence of oxidizing agent and reducing agent. If I want to test for any reducing agent, I can use I want to test for any oxidizing agent, I can use a reducing agent to test for the presence of oxidizing agent. The observation will be colorless solution turn yellowish brown. The explanation is when they are oxidized by the oxidizing agent. So if I add a reducing agent, an oxidizing agent must oxidize the reducing agent. So how I see the difference is, if there is a reaction in your iodide and there is a change in color, I can safely say that the change in color is due to the presence of oxidizing agent. So if I have to check for the presence of reducing agent, the opposite reaction can take place. I can use oxidizing agent to test for reducing agent. So my oxidizing agent can be a purple acidified potassium permanganate. If it turns colorless, I confirm that the iodide is present. I confirm the reducing agent is present in the solution. So in summary, if I want to test for reducing agent, I add oxidizing agent. If I want to test for oxidizing agent, I add reducing agent. If there's any color change, then the particular oxidizing or reducing agent is present. In summary, I want to leave with you this shoe mnemonics. The shoe mnemonics will give you hydrogen is a loss for oxidation. Oxygen is a gain for oxidation. Electron is a loss for oxidation. Oxidation state is a gain in oxidation. Thank you for your attention.